All right, let's do this. Hello. Hello to Learn Web3 with CLNY. I am streaming this and also recording for, I guess, future generations of developers. So what are we doing here in this weird experiment? I guess we are trying to see what it is like to be a Web3 developer, meaning we are not writing Solidity contracts. We are not writing Ethereum smart contracts, but we are basically Web2 developers, and we want to talk to smart contracts, and we want to see what this is all about and how it's actually being done. So this is an important differentiation that I want to make for this course. This is not a course on how to become a Solidity developer. This is not a course on blockchain 101. This is something I think is more targeted at people who already work in web. They know JavaScript and they want to extend their knowledge and want to go into Web3 and maybe want to develop or help develop dApps in the future. So yeah, what can we do here? What are we going to do in the next couple of weeks, actually, is we discuss and learn about the basics of Ethereum smart contracts. Not how to write them, but definitely how to read them. And everything that you need to know as someone who develops a dApp against a smart contract. We want to learn how to use libraries like ethers.js or web3.js to have a better time talking to smart contracts and interacting with them. And at some point, we are going to build a web application that does exactly that. We want to have an application that implements a bit, which is basically a small dApp, which can be already used and will work against the CLNY smart contracts that we have deployed already. The other main differentiation I wanted to make about this is that I want to kind of embrace the format of streaming, of Twitch streaming. So this is not a complete course on how to become a Web3 developer. This is not comprehensive in any way, but I hope this is going to be a lot of fun. And I kind of want to portray the real struggles and the real problems that people come across when developing dApps. And that means I don't want to take any shortcuts. I will record everything that I'm going to do, and I will not prepare anything before the session, apart from like some light documentation or maybe references or things like that. But I won't write any code outside of the streaming sessions. And I don't know how long this is going to take, but I think this is going to be fun. At the same time, another big advantage of this is that this is real time. That means not only real time, meaning, oh, you can look at me code and interact with me at the same time, but no, you can just join the project in between sessions and help coding and ask questions and just be involved in the project that we are building. So I think that's pretty cool. And yeah, I'll try to help you and guide you along the way. And I hope you'll have a lot of fun with this. All of the sessions are going to be recorded. I will not record the screen, like the Twitch screen or the questions that have been asked, but I will repeat the questions so people can actually see what happened in the past. Okay. Right. So with that out of the way, what are we going to do today? Today, we want to look at a smart contract. And we want to look at a smart contract from like a web developer's point of view. That means we don't really care about the implementation. We don't really want to know what's going on in the background. We just want to know, how do we talk with it? How do we make it do whatever it's supposed to do from our dApp, from our JavaScript application? So maybe we jump right in. Maybe we just do that. So let's just look at a contract. The contract I picked for that today is a fairly straightforward one and also very popular one. It's just the ERC20 token contract. So I pulled up the specification here. What does it mean when the contract is an ERC20 compatible contract, or when is a contract ERC20 contract, a token contract? Essentially, what all of this means is it implements all of these functions and these events. It doesn't mean that it only has to implement these functions, but these are the ones that are necessary in order to be compliant with the standard. So, I mean, what do we have here? We have a method called name, we have a method called symbol, we have a method called decimals, total supply, and then a couple of other methods that we can call and that might be sort of familiar to you or not. I'm not planning to go into details what every of these do. I mean, it's kind of, for a lot of them, it's kind of straightforward. Total supply just means, for example, it's just the amount of tokens that exist for this contract. Balance of an address, like how many tokens does a particular wallet address own, things like that. We can certainly discuss this. If you have any questions for any of these, then we can obviously, I mean, in general, just ask questions if you feel like it. I'll try to answer them to the best of my knowledge, but this is how we go here. So what does it mean? The contract implements these methods and also these events. Just a quick primer. What are events? Events are basically logs that are being, it's just, you have to kind of imagine as a big transaction log or a log of things that happened. When you want to like store something alongside your transaction or alongside your state change that you did in the Ethereum virtual machine. So this is the ERC20 specification. So what does it even mean when we execute a function here or when events happen? I kind of want to exclude events for now. I get back to them later at a later point because it's kind of it's a bit confusing for a beginning example. So we just skip events for now and just go into the methods, and like we talk about events later on. So what does it mean when I call a method? In general, in Ethereum, in the EVM, which is a state machine, that means it can only transition between well-defined states in very well-defined ways. So whenever we want to change the state of the EVM in general, that also means like we want to store something on a contract, or we want to, let's say we want to mint some tokens on a contract, or we want to send some tokens to someone else. All of these are state changes, and we have a way to transition from one of these states, that meaning like I have 0 tokens, to another state, meaning like I have, for example, I have 100 tokens. So how does it work? Every time we want to make a change to the state, we have to issue a transaction. That means we sign the transaction with our wallet. We get to that later. And we send them off to an Ethereum node. What is an Ethereum node? I will explain that later as well when we get to the JSON RPC protocol. So we send our transaction off, and then due to the blockchain, how the blockchain works, I'm also not going to explain this here, but the transaction will be included in a block, and then during that time, the state of the whole EVM is going to change. That means I can only make changes to the state of my smart contract or of the Ethereum virtual machine in general if I issue a transaction. This transaction is not free. There will be gas costs, as you will know. Most of the time, you will see when like you open MetaMask or whatever, you'll see that your transaction that you're wanting to make will incur gas cost, and that's due to the state changes not being free because the miners wanted to be paid in the past. Now it's the validators that want to be changed. I want to be paid. So state changes cost money. Storing data on the blockchain costs money, or let's say gas. What is free though is asking for the state. That means if you want to ask a smart contract, hey, what is this kind of value that you stored? Like tell me about this value. Tell me how much is it? For example, that would be total supply here. If we look at that, that would be a value that we can just ask for, and we will get an answer, and that is free. And this is what is usually called a function call, a method call, or just a call in Ethereum. Usually you can differentiate between these two things. You can either have a transaction or you have a call. Transaction costs money, call is free. So how do we know what is a call and what is actually a transaction? So that's actually, in this case, is quite easy to see. For all of the calls, we have this, what is called a modifier in Solidity. We have a view modifier here. Whenever there's a view modifier, this means this is something that is only for viewing or for just calling, but not for changing the state. So this function will never change the state. Whereas here, for example, transfer, we don't have that modifier. So that means this will most likely change the state. Again, if you have any questions, let me know. So this kind of first lesson, as you can already kind of see, is going to be quite, I mean, it's kind of going quite deep compared to the rest of our course, but I want you to know what we're dealing with, what this black box is that we're dealing with later on. If we're using a library like Ethers.js or Web3.js or something like that, all of this is going to be abstracted for us. But I think it's important to have at least these kind of basic understandings of what's going on. And if any Solidity developer is watching, like, yeah, you probably, I mean, I definitely didn't get everything right, and probably like I'm lacking terminology in some cases, but please bear with me. This is a web developer's view on the whole matter. So I guess for my personal case, it never hurt me to have this basic understanding of it. Okay, let's look at the real example really briefly. This is an implementation, or let's say it's the interface of an implementation of the ERC20 standard by OpenZeppelin. They usually have pretty well thought through implementations of their standards, and with some nice convenience functions and extras. So whenever you're looking for some really basic standard smart contract like ERC20 or ERC271 NFT contracts or anything like that, OpenZeppelin is always a good address to go to. So if we're like, you can see we're in contracts token ERC20, and you can see there's like ERC20 and IERC20. ERC20 in this case is the actual implementation. You can see that there's like some things going on in the actual in the actual functions. But for our purposes as web developers, most of the time the interface will be just enough, because this is what we talk to. And as long as we know what these functions do, if it's like, let's say it's well commented, for example, here we have like really nice comments. We will know what this does. We have all of the information that we need to talk to the contract, really. All right. So again, let me know if you have any questions regarding this. I feel like this is the real basics. I don't want to go too deep here. Again, this is not a Solidity course, so I guess we just leave it at that. Now I kind of want to go into the protocol here. Oh, the difference. So there's a comment. Can you explain more the difference between the IRC20 and the ERC20? Okay, so yes. When we look at the ERC20.sol, we will see that here is the actual implementation of the smart contract. So we will see that everything, like we have some assignments here, we have some function calls, some internal function calls, we return some values. So there's some implementations going on in the actual functions. But as web developers, we usually don't care about like how it's actually being done. So we only care about like what is the function called, what does it do, what arguments does it take, and what does it return, if it returns anything. And this is exactly what the interface is for. The interface kind of strips away all the actual implementation of the of the functions, and just leaves us with, oh, this is what you need to know. This is the way to interact with the smart contract. So this is kind of the, if you want to say, this is kind of the application programming interface that we have to the contract. I hope that makes sense. Yeah, basically you can see it as something that is just giving you the bare minimum information that you need as a developer. You can also see it as some sort of specification. This is something that needs to be there. You could also see this, for example, as an interface. We'll see that this looks kind of similar, right? It's kind of, it's basically the same, exactly the same thing. Okay. So how do we actually talk to the smart contracts? How do we make requests to the blockchain, which is kind of feels like this blob of things that are interconnected, and figure out what's what and what's the actual state of it. So how do we ask it for stuff? How do we make transactions? How do we like interface with it, really? And this is where the JSON RPC API comes in. So whenever you see something interacting with the blockchain or the Ethereum blockchain, then it will be most probably using the JSON RPC interface. A lot of times it will be very abstract. It will be like abstracted away and you won't be able to see it. But I want to show it to you to kind of demystify it a little bit. This is kind of something that was very unclear to me in the very beginning. Is like, how do I even talk to the blockchain? How do I even make transactions? And in the end, it is just a HTTP request to an Ethereum node that can then either answer your question if you're making a call, or take your transaction and propagate it in the Ethereum network. So what you're doing is you're basically just sending HTTP requests to an Ethereum node. And these HTTP requests have a certain format so that the node can understand it. There's also like one important part to this is that not all of the Ethereum nodes have this API or expose this API, the JSON RPC API. It's only the ones that are publicly accessible and that are basically maintained by someone and secured by someone, so that there's no malicious activity or kind of trying to prevent malicious activity there. So you won't find so many of the Ethereum nodes that are actually in the network will have this API exposed. Luckily, we as CLNY, we run such a node and we can ask it questions. And this is exactly what I want to do now. I want to like make a very raw HTTP request to the CLNY node to just see what's going on under the hood here. Like what is actually really happening between these two computers, to see what all of these libraries like Ethos.js and Web3.js are doing under the hood. So let me just quickly find my notes here. Okay, so what I said is I do not want to skip anything. So what are we going to do here? We are going to actually create a project and create some JavaScript code to talk to the CLNY node. So what we're doing here is just an npm init -1. This is, I'm doing this to be able to install some modules that we need. For example, I mean, one module that we need is Axios. And I thought Axios is probably a good idea because a lot of web developers already know about it and kind of know how to use it. So I'm just going to use Axios to communicate to our RPC node. And if you feel like this is turning out to be very cumbersome, yes, it is. And it's also very confusing, and it's also not a very nice API. And this is why we need libraries like Ethers. But I just wanted to show you how you would do it without Ethers to kind of demystify it. And then we can just move on to Ethers and forget about this really, because it's just so tedious. But I want you to see it at least once. So if you cannot make sense of it, what we're doing now, or if you feel like you're lost, it's fine. You won't ever do this, ever, really, as a developer, except when you're like developing something like Ethers.js yourself. Okay. Let's create a file, RPC test. My editor is complaining about this not being TypeScript, but we'll make it work. So let's install Axios so that we can use it. And then we say we require it. So this is just, oops, what am I doing? This is just basic JavaScript code. So what do we need to know? How do we make this? Here I linked to, this is in the link, by the way, of the agenda file of today. I will upload that to a repository and send you the link later on, or I mean, I'll send you all of the links later on anyways. So what are we looking for? We're looking for ETH call. So what does it say? Executes a new message immediately without creating a transaction on the blockchain. This is what we want. So like for now, we want to just make a request to a smart contract. We just want to know, like, want to ask it a question with an immediate reply. So we don't want to change the state, because that requires a transaction, and the transaction is much more complicated to construct, especially manually, like we are about to do now. So we want to do ETH call. Feel free to explore this API. There's a whole bunch of things that it supports, a whole bunch of different kinds of requests or function calls that you can make. For now, we just discuss ETH call, but there's also, for example, ETH send transaction, ETH send raw transaction, or what else is there? Like you can request the block number, you can do all sorts of things, but with ETH call and ETH send transaction, you mostly covered like 90% of the use cases that you want to do. Depends on what you're doing, but this is usually when you're developing and adapt, this is usually what you do. So let's just make this request. We can see that here's an example. They nice. It's very nice of them. They always provide curl examples here. So here it says we need to make a post request to our RPC node. So we do axios.post, and then we put in the address of CLNY's RPC node. HTTPS. And so, as I said, CLNY is running a node that allows you to interact with it and send requests to it. So this is what we are going to do now. And as you can see, we have to specify the version. JSON RPC 2.0. Then the method, oh yeah, the call method is eth call. That's what we want to do, eth call. Then we do params. This is, you can see it here. This is kind of always, it always looks like this. You always have JSON RPC, then a method, then params, and then an ID, which is just going to be echoed to you. So, and the params is an array. And this is not the parameters of the function that you want to call, but it's more like all of the information that you want to send to the node that you want to ask a smart contract. So the node currently doesn't know like which smart contract do you want to talk to. You have to tell it that as well. So this is in the params. So in the params, it's a bit of a weird API as I said before. So in the params, we have the first argument here is an object, and that contains 2. So what are we even going to do? I thought we want to maybe talk to an ERC20 token and ask it for maybe the balance of a certain wallet address, like a, I don't know, a token holder. We just take any wallet address and ask it whether it has CLNY tokens and how many. So I'm using a specific address here, just a random address I picked from the CLNY token holders. But for now, we are taking the contract address of the CLNY token. Let me see if I can copy this. We're taking the contract address of the CLNY token on Gnosis chain. So this is CLNY on Gnosis chain. This node is also a Gnosis chain node, so that's why we need to use the Gnosis chain address here as well. So, and now, what do we want to say? What do we want to ask the CLNY contract? What is the actual request? So this is where it gets complicated, and this is like, I don't really need everyone to understand or reproduce this, but I just want you to see it. I want you to see how ridiculous this is if you have to do it yourself. So what we want to do is, which function do we want to call? We want to call the balance of function. So what do we need to do? So we go into the Solidity ABI specification. I also will link to that later on. And here it says we need to give it a couple of things. The method ID. This is derived as the first 4 bytes of the catcher cache of the ASCII form of the signature. The first parameter and second parameter. Here we have 2 parameters. We just want to have 1 parameter. As we know, in the balance of, we have 1 parameter, which is the address. So how do we get the method ID? As we know, the method is balance of address account. So the ID is a hash. That means we will now, you can see it here already. We will now hash our method signature. Here we remove the name of the variable internally. We're not really interested in that. And as I had it in here before, so we just need it once. So, and this is basically the function name and all of the parameters separated by comma. It would be like if it was a uint, then it would be uint 256 or something like that. So, but here we have only balance of, and then it's an address. Address is a type in Solidity. So we just say address, and this is actually then our this is our method ID. Actually, it's not really the method ID. It's the hash of the signature. To get our method ID, we need to get the first 4 bytes. And as we know, if computer science taught me anything, then it's 1 byte is 2 digits in hexadecimal. So we have 1 byte, 2 bytes, 3 bytes, 4 bytes. So, and this is our method ID, 8 digits. It's always 8 digits. And now we say, okay, it's hexadecimal, so 0x, our method ID. So, okay, so far so good. We have a method ID. What now? Okay, now it wants the first parameter as a value, as a number, padded to 32 bytes. 32 bytes means, padded to 32 bytes means the whole thing needs to be 64 hexadecimal digits. But an address, let's say, okay, let's say we want to have this address. I just copied a random token holder of CLNY. That means we have to pad it. That means we have to add more zeros. We remove 0x because we already have it. So we have 40 characters here. That means we need to add 24 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. Yeah, sure. You would never do this manually, but for, I mean, this is kind of the in this kind of presentation, we just do whatever needs to be done, and we just do it manually. Okay, so to recap, we send the params. We send it to a contract, which is the CLNY on Gnosis chain. Let me maybe comment this better. Let's put this here. Maybe say method ID first 4 bytes of Kachak 256 hash of the method signature. This is how it works. Plus 32 byte padded first argument. Wow. Okay. And now, remember, we're still in the params section here of this post call. So, and the second one is, I think, optional. I'm not super sure, but this would be you want to know, or you want to specify the block to get this answer from. Like, what block are you looking for? In what block are you looking for this answer? And as we are interested in the most recent value of it, we just specify latest. That means latest block. Okay, so far so good. Now we say then, and we get a response. And mind you, this is still the HTTP response. And then we just console.log response, and I know that it's called result in the data field of the Axios response. Okay, this is our manual call. Let's go here and see if it works. If we say node RPC test.js, Yeah, we got an answer. This is, I know this is not very convincing, but let me tell you that this is roughly 128,000 CLNY. So why is it that? This is hexadecimal, so we have to first convert this. I can tell you already, this is a number that is too long for JavaScript to handle. So I am just gonna paste it into Wolfram Alpha here and ask it, okay, what's the actual decimal form? Okay, so I told you 128, roughly 128,000 CLNY for this address. So why is it such a big number? So the answer for this is that all of the values that smart contracts give you are denominated in a way. And that is you can basically say that 1 ETH is 10 to the power of 18 way. So it's a really big number. So it's basically 18 digits after the integers, after the first integers. The reason for that is that you want to be able to denominate really, really small denominations of a token. So if you say I have 1 CLNY, maybe you just want to be able to denominate it in 1/1,000,000th of a CLNY or something like that. So the token decimals here basically specify how fragmented it can get, like how the first or how the smallest entity is going to get. And usually that's 10 by the power of 18 or 18 digits. I guess you can specify it in your token. Actually, when you create a token, you will see it, and you'll also see that ERC20 has a decimals function that will give you the amount of decimals here. Most of the time it's 18. Okay, so what do we need to do? We need to divide it by 10 to the power of, I have no idea how to write that in Wolfram Alpha. So maybe that's, yes, okay. So now we can see decimal form 128,981. So how the hell are we going to do this in JavaScript if we don't have the capabilities of handling these big numbers? You can see here, I pulled this up from the MDN. The maximum number that we have is, actually, I don't really know. It's definitely not big enough for most of the numbers that we want. This is, I have no idea. This is a big number, but it's still like too little to what we are expecting. Most of the time, Solidity or smart contracts will give you numbers that are UN256, so 256 bits. JavaScript just gives you 53 bits as the biggest number. So we have to find a solution for that. And this is where big number comes in. Big number JS, let's see, or BNJS, there's many implementations. This is the one that Ethers.js uses. And this helps you to basically, you're able to store arbitrarily big numbers with this in JavaScript and calculate with them. And this is what you need to use when talking to smart contracts. Luckily, libraries like Ethers.js or Web3.js will have their own implementations, or this implementation actually shipped with it. So you don't need to worry about not having this. But this is a layer of complexity that is definitely needed. And yeah, this will give you, I guess, all sorts of troubles down the way. I feel like it's too much to go into a lot of details here, because I think we can make a whole episode about big numbers, and maybe we should do that actually. But for now, just be advised, you will need it because you will deal with insanely big numbers all the time. So just make all of the numbers that you have just big numbers. Maybe we can just quickly see how this would be done here. So if we just install bn.js, I don't really know, is this, okay. And in our code, we just say require bn.js, and let's look at the documentation here. And we can say what do we balance equals new, this was balance equals new bn, and then we say response data result. This is a string here, and I think it will just do whatever it needs to do to parse it properly. I think we have to tell it that it's actually a hexadecimal string, as it does it here. And yeah, let's see what happens if we say console.log balance to string, balance to string 10. So strings is always working, obviously, but it's really hard to calculate with strings. So we just string. We just use them to display the numbers. Okay, let's see what it does. Okay, this doesn't work. Invalid character. Oh yeah, okay, it doesn't like the 0x. So we do substr 2, I think. Wow, I haven't been writing JavaScript for such a long time. Okay, there we go. Whew. So we get the correct answer, and it's still too big. So how do we calculate that? We can say we need another big number, which is let's call it way. And actually, it's not really way. Let's call it ETH. And we say new bn 10, and then pow. I think. Let's check. You have the documentation always right there, I hope. Let's see, pow. Yeah, raise 8 to the power of b, 10 to the power of 18. But I think we also have to say new bn. So you will see that it's a bit easier with ERC20, but here you will have to always have a big number from the numbers that you take. And if we say balance, I think div ETH to string 10. Let's see if that worked. Oops. Yeah, there we go. And this is the actual number that we're expecting. So when you deal with token values, or especially token values or Ether that comes back from smart contracts, then it's most of the time denominated in ETH, in way, and then it's going to be like a super big number, and then you have to divide it by the decimals of the token. So if you really wanted to be sure here that you're doing the right thing, you would get with another call, you would get the amount of decimals from the token and then divide by that number. But I'm sure in this case that it's 18. Okay, wow, this was a hell of a ride. But luckily, you don't have to do any of that. I mean, except for the big number stuff later on. But you don't need to worry about the method ID. You don't need to worry about what like the hashing algorithm is, or where to get this hashing algorithm from, or how to apply it, or any of that. You can just use ethers.js or Web3.js, but ethers is the one that I'm familiar with and that I'm going to be using throughout the rest of this course. So what is ethers.js? Ethers.js is basically doing the same thing that we just did, but it makes it easier for us to do this whole thing. We basically just say, I want to call this method on this contract, and it will just work. So how does it do that? I mean, you kind of have to give it the information about the smart contract, because smart contracts are, you cannot ask a smart contract, hey, what operations do you support? It's just a binary blob on the EVM, and it's just not going to give you that information. So you have to know which methods a smart contract supports. How do you know that? When a smart contract is compiled, it will also create ABI files, JSON files. And these define all of the interface. ABI means application binary interface. So that means it gives you all of the information that you need to talk to the smart contract. It gives you all of the method signatures, what arguments the methods take, what types these methods are, and so on and so on and so on. So all of this is provided during the compilation time of the smart contract, and this is most of the time provided by things like Etherscan. Let me see if we can look that up. If we go to Gnosis-scan, I think it's too new for Brave. So go to Gnosis-scan, and maybe put in the address here. Read contract. Okay. So in this case, we don't have the source code here. You can see that this is the whole contract binary code. It's not much to it. So a lot of times let's see about other tokens. Let's see about this. Let's see about Tether contract. Oh, this is verified. That means we probably can read it. Not sure what to say. I've never done this. There we go. Okay, so here we have all of the ABI. I don't know. There was a way at some point to get the whole JSON output of this. In any case, let me show you how it looks like. We have in CLNY a repository called ABIs, and this is where all of our contract ABIs live for all of our contracts. So for example, if I go to the newest version, because CLNY contracts are versioned, that means we also have an ERC20 token in here. So let's look at that. And you can see this is the ABI. This is how an ABI would look like for an ERC20 token. And as I said, usually you get that when you compile the contracts. That means if you're a web developer, talk to your Solidity developer and ask them for the API JSON files. You take all of this, stuff it into Ethers, and Ethers gives you a nice interface that you can work with. But again, this is what we're going to do next time. We're going to take a little kind of a deep dive into Ethers, or let's say maybe not a dive, but a snorkel, and explore what it does for us and how much easier it actually is to use Ethers as opposed to whatever we did here to talk to the smart contracts. Again, I will link to all of what we have here in a repository. Let me put that into the chat. I actually created the repository earlier. Join CLNY. Let's go to the SDK. If you have any questions, let me know in the chat. Okay, there we go. Ready to snorkel. Okay, learn Web3. So this is the repository. I'll put it in the chat here, and I will also link it in the Discord. There's all of the links you need. There's some like preliminary agenda for all of the next lessons. I guess I will call them. Let's call them lessons. For now, this should be it. I know it was a little bit of a dense thing to do, and it was kind of it was an experiment. I just wanted to show you how cumbersome it is to actually talk to a smart contract if you don't have anything else at your disposal. So I hope this was enlightening. But from my side, that's it for today. That's what I wanted to cover. Let me see. Do I have anything else in my agenda? Big numbers, APIs. No, we talked about everything. Yeah, let me know if you have any more questions or comments. Otherwise, we'll leave it at that for today. Thanks to everyone who joined, and I will post that to post this video to YouTube probably. Yeah, and maybe cut out some stuff. We will see, but I think it's going to end up at around 1 hour. So yeah, thanks everyone, and have a great day or evening wherever you are. Bye bye.